am Moses Oluwasegun. You are welcome back to my YouTube channel. This is Program Mathematics, and I am the tutor on this YouTube channel. In the last video, I explained the determinant of a 2 by 2 matrix, through which I also explained the minor of a matrix. Now, today I shall be discussing the cofactors of a matrix. The cofactor of a matrix. Now, the cofactor of a matrix, the cofactor of a matrix is the matrix of the minor of the minors. Okay, now in the last video I explained what minor of a matrix is. Okay, that is, the minor of a matrix is the determinant of the leftover matrix when the row and column to which an element belongs, okay, are deleted. For instance, now if you are given matrix A to be the matrix 2, 1, 4, 5, having this element, the minor of matrix A, okay, the minor of matrix A in this case refers to the row that this element, let's say for instance, I want to calculate I need to delete the row and column to which an element belongs. So when you want to calculate the minor of a matrix, minor is calculated for each element of the matrix. Okay, the minor corresponding to 2 means delete the row and the column 2 belongs. The leftover determinant of the leftover matrix is what we refer to as the minor corresponding to the element 2. Minor corresponding to element 1, okay, means deleting the row that 1 belongs and the column that 1 belongs. We find the determinant of the leftover matrix. In this case here, this is just a single value, so the minor is going to be this 4 here. Okay, so we can go on like that. Now, in the case of the cofactor means now that having obtained the minor corresponding to each element of the matrix, then the next thing is we form those minors into another matrix. That matrix obtained is called the cofactor of the given matrix. Now, the cofactor of a given matrix is denoted by letter C, the capital letter C. Okay, so it is denoted by capital letter C and is denoted by C and defined, okay, is defined as, okay, now Cij is equal to minus 1 raised to power I plus j, then Mij. So the Cij here shows that the cofactor is calculated also for each element of the matrix. So where Mij represents the minor corresponding to the element Aij, So what this simply tells us is that for the cofactor of any given matrix, we calculate cofactor for each element, just the same way we calculate the minor for each element of a given matrix. All right, now let's see how this is used. Okay, let's see how we calculate the cofactor of a given matrix. Now, as an example, okay, we want to find the matrix of the cofactors of matrix A, which is 2, 1, 4, 5. So let's take a 2 by 2 matrix here. Okay, the same way you calculate the cofactor of a 2 by 2 matrix, just the same way you do that of a 3 by 3 or 4 by 4 square matrix. Okay, so we are given the matrix A equals 2, 1, having the elements 2, 1, 4, 5 here. So we need to obtain the cofactors of matrix A. So in this case here, let's look at the solution to that. So matrix A is 2, 1, 4, 5, and we know that the cofactor Cij is minus 1 raised to power I plus j, then the minor corresponding to the element Aij. Okay, so don't forget I represents the row number, j represents the column number. So in this case here, Let's obtain all the minus or the signs first. So for C11, this first row, first column, element corresponding to 2. That's first row, first column. Okay, so find C11, C12, C21, and C22. So in this case here, our C11 would mean the minus 1 raised to power 1 plus 1, M11. And in this case here, this one minus 1 is 1 plus 1 is 2, minus 1 raised to power 2 is positive 1. So this is simply going to give us M11. Then MC12 is minus 1 raised to power 1 plus 2. Then this will be M12. Minus 1 raised to power 1 plus 2. 1 plus 2 is 3. So minus 1 raised to power 3 is minus 1. So this will give us negative M12. And then C21 as well, minus 1 raised to power 2 plus 1, M21. So in this case here, 2 plus 1 again is 2. 2 plus 1 is 3, okay? So minus 1 raised to power 3 is minus 1. So this one here will give us, that's minus M21, okay? Minus M21. Then for C22, that's second row, second column, minus 1 raised to power 2 plus 2, M22. And so 2 plus 2 is 4, minus 1 raised to power 4, that is plus 1. So this will give us positive M22. Okay, so plus, minus, minus, plus. All right. So now in this case here, all we need now is to find this M11, M12, M21, M22 before we then write out the cofactor. Now in this case here, M11 means the determinant of the leftover matrix. Okay, when we delete the first row, first column, that's corresponding to 2. First row deleted, first column deleted, we are left with 5. So M11 here is simply equal to 5. Okay, so M11 is 5. M12 is first row, second column. This is first row, second column. Delete first row, delete second column. Okay, so I left with 4. So M12 is 4. Because of this minus, this will give us minus 4. Then M21, second row, first column. Second row, first column, delete them. Second row, first column, delete them. We're left with 1 here. So M21 is 1. Because of the minus here, we have minus 1. Okay, so this is minus 1. While M22 is second row, second column. Delete second row and second column. When we do that, we're left with 2. So M22 is 2. So this is simply 2. So the matrix of the cofactor now, which is capital C, is therefore given as C11, C12, C21, C22. So C11 here is 5. C12, okay, is minus 4. Then C21, second row, first column is minus 1. While C22, second row, second column is 2. So what we have here is the matrix, the matrix of the cofactors of the matrix A equals 2, 1, 4, 5 in this case. So if what you are given also is a matrix of 3 by 3 order, okay, the same thing is done, only that in this case here, we're not going to stop at C22, rather we are going to stop at C33. Now as an example, let's see how we take that of a 3 by 3 matrix. How do we find the cofactors of a 3 by 3 matrix? So another example here. So we are given matrix P to be the matrix 4, 2, 1, minus 3, okay, 5, 0, minus 2, 2, and 6. So we want to find the matrix of the cofactors. Matrix of the cofactors. So now solution to this. Now don't forget the cofactor is defined Cij equals minus 1 I plus j, then the minor of the minor corresponding to each element of the matrix. All right, so if we are to find our C11 here, in this case here, don't forget this cofactor will be C11, C12, C13, C21, C22, C23, C31, C32, C33, because this is a 3 by 3 matrix. So we calculate the cofactor corresponding to each element of the matrix. So meaning 1, 2, 3, 4, 5, 6, 7, 8, 9. We're going to have 9 cofactors because this is a 3 by 3 matrix. All right, so in this case here now, we need to calculate C11. Okay, C11. Okay, we need to calculate C12, C13, C21, C22. Okay, so we need to calculate C22. Okay, you can continue this on your own as well if you want to try this out. C22, C23, we need C31, C32, and C33. So these are the cofactors that we need in order to calculate to find the matrix of the cofactors here. So let's obtain the signs first. For -1, this is going to be +1. So this is M11 here. For C12, you can put the I and j here. This minus M12. For C13, this is +4. That's 4 positive. So this is M13. C21, the sign is going to be negative. That's M21. For C22, 2 plus 2 is 4. -1 raised to the power 4 is positive. So this is M22. We're going to get these values straight from the matrix here very soon. Then for C23, 2 plus 3 is 5. -1 raised to the power 5 is negative. So this minus M23. For C31, okay, 3 plus 1 is 4. -1 raised to the power 4 is positive. So this is M31. And then C32, that is 3 plus 2 is 5. So -1 raised to the power 5 is negative. This is minus M32. Then C33, 3 plus 3 is 6. Okay, -1 raised to the power 6 is positive as well. So in this case here, we have M33. Now, let's get these values from here. M11 is the minor corresponding to the first element here, first row, first column. So don't forget, you delete the first row, the first column, and find the determinant of the leftover matrix. So in this case, 5026. 5 times 6 is 30. So this is 30 minus 2 times 0 is 0. So this is 30 here. So for M11, we have 30. For M12, we are deleting the first row, the second column. Delete that. First row gone, second column gone. We're left with -3, 0, -2, and 6. So determinant of this, -3 times -6. So this is minus first because of this minus here. So put the minus first here. So -3 times 6 is -18. Okay, -2 times 0 is 0. So if we simplify this, -18 minus 0 is -18. -18 times this minus here will give us +18. M13 means first row, third column. First row, third column. Delete those two. So -3, 5, -2, and 2 left. So -3 times 2 is -6. We have -6. -2 times -5 is -10. So we have a minus here. So -6 minus -10, that is +4. So this is positive M13. So this is +4 here. So we have -6 minus -10. This is +4. M21 means second row, first column. Second row deleted, first column deleted. So we have 2, 1, 2, 6. 2 times 6 is 12. 2 times 1 is 2. So 12 minus 6. So this is minus, bracket 12 minus 2 times 1 is 2. So 12 minus 2 is 10. Times this minus 1 here, we are going to have minus 10 together. That's for second row, okay, first column, 12 minus 2. Then M22, second row, second column, second row, second column deleted. So we have 4, 1, minus 2, 6 left. So 4 times 6 is 24 minus 2 times 1 is minus 2. Okay, and so in this case here, 24 minus 2, that's 4 times 6, 24, minus 2 times 1, that's minus 2. So 24 minus 2, that's plus 26. Okay, so this is 24. This is 24 minus 2. So we have plus 26. Then for M23, second row, third column. For second row, third column, second row here, third column deleted. Okay, so we are going to be having this 4, 2, minus 2, and 2 left. Second row, third column, 4, 2, minus 2, 2. 4 times 2 is 8. So we have 8 minus 2 times 2 is minus 4. So 8 minus 4. But there's a minus here. So this is minus 12 altogether. You can do that as well on your own. So you can pause the video and try the other 3. Okay. And then compare the result with what will be displayed on the board here. Now for the third one, C13, M13, M31 rather, C31, M31. So M31 means third row, first column. Third row, first column. We delete those 2. So we'll be left with 2150. Okay, so 2 times 0, the determinant of the leftover 2 by 2. 2 times 0 is 0. 5 times 1 is 5. So we have 0 minus 5. 0 minus 5 is minus 5. So this is minus 5 here. Then for M32, third row, second column. Third row, second column. Delete third row, delete second column. We have 4, 1, minus 3, 0 left. So 4 times 0 is 0. Minus 3 times 1 is minus 3 here. Right? So in this case here, we have 0 minus, that's plus 3. But there is a minus here. So this is minus 3 in the end. And then the last one here is the C33. Corresponding minor is M33. So in this case here, delete third row and third column. Third row, third column. Delete those 2. So we'll be left with 4, 2, minus 3, 5. 4 times 5 is 20. Minus 3 times 2 is minus 6. 20 minus 6 is plus 26. So together here we have plus 26. So now we have obtained the cofactors of each element in this matrix. And so now let's obtain the matrix of the cofactors. So the matrix of the cofactors represented as capital C, okay, is the matrix C11, C12, C13, C21, C22, C23, C31, C32, C33. Okay, so which in this case will give us C11 is 30, C12 is 18, C13 is 4, C21 is minus 10, okay, C22 is 26, C23 is minus 12, C31 is minus 5, C32 is minus 3, C33 is 26. So this is the matrix of the, this is the cofactor of the matrix P, which is given as this. All right, so this is how the cofactors of a matrix are obtained. So when you are given a matrix and the question simply asks you to find the matrix of the cofactor, or simply asking to find the cofactor matrix, or simply cofactor, in this case here, just take the definition. Cij equals minus 1 raised to r I plus j times the determinant of the leftover matrix when the row ith row and the jth column corresponding to an element are deleted. That's the minor, okay, the mij. So what I did first here is obtaining the sign corresponding to each element. Okay, for minus 1 here, for the first row, first column, C11, 1 here means 1 plus 1 here, row column 1 plus 1, that is 2, minus 1 raised to power 2 is plus 1. So that means that the sign convention here is plus. Okay, and if you have not forgotten, in one of the videos under determinant, I gave you the sign convention for the determinant. The first sign is positive, followed by minus, then positive, plus, minus, minus, plus, minus, alternate signs here, plus, minus, plus. So this is exactly what we have done here. So if you check this now, for first row, plus, minus, plus, plus, minus, plus. Second row, minus, plus, minus. You can see that here, minus, plus, minus. Third row, plus, minus, plus, positive. Okay, so every other thing there now is to how to get the minor. Don't forget the minor. The minor simply means the determinant of the submatrix, okay, when the row and column to which an element belongs are deleted. So minor is calculated for each element of the matrix. So you calculate the minor for 4, minor for 2, minor for 1, minor for -3, minor for 5, minor for 0, minor for -2, the minor for 2, and minor for 6. That is exactly what we have done here. So when we have all of these together, we can then put them together into a matrix. All right. So please, if this is your first time of joining this YouTube channel, please, I will implore you, I'll plead with you to please subscribe to my YouTube channel, recommend the channel, like the videos, give me thumbs up on the videos, and at the same time, use the comment section to reach out to me. Whichever question you want to ask, please use the comment section or check the video description. You see my contact as well there, where you can as well reach out to me. All right. So in the next video, okay, I'll be talking about the inverse of a matrix. Okay, inverse of a matrix. Of course, please, in case you have missed out, matrix is a full playlist on its own, so you can help yourself with other videos that must have been made on this aspect of matrix, so as for you to catch up with what we have here. All right, so in one of the videos also, I'll be explaining the adjoint of a determinant, adjoint of a matrix rather. So now, once you know how to find the determinant of a matrix, you can find the cofactor of a matrix, you can find the adjoint of a matrix, you can find the inverse of a matrix. Then you can as well solve systems of equations using the matrix method. All right, all these are discussed in this video. So I expect you to please go through the videos and then at the same time help yourself with the ones you have missed out. All right, so please, let's see in the next video.